Well, thanks for being here. Get things going here. Just trying to work on getting a bit of a demonstration going there. So I went to your guys' great website, and I realized I needed to do a combination of things. I needed to do, well, let me back up a little bit. Fusion is relatively new technology. And so I've been in there from the beginning with one of the beta test sites and all that type of stuff. And I found that I've had to, this really isn't the right word, but dumb down the presentations over time as it becomes more of a commodity. So I'm making assumptions here that you guys probably know about a lot of stuff. You probably heard about DMR and all that kind of stuff and maybe aren't too familiar with Fusion, but you're technical people. And you like to dig in and play with hardware and mess with things. You want to know how this stuff works. So I kind of merged two presentations together. They're each about an hour long. So we'll try to go through this fairly quickly. So this is kind of an experiment for me, but give me feedback. If the stuff is like, oh God, we know this stuff, move it along, just let me know. So anyway, I stole the title from the technical presentation, which is Fusion from the Inside. So what I'm going to do is, this is the general presentation, a little bit about Yaesu, why digital. Why digital? If you can do everything you want with FM, and FM's working great, why use digital? Just because it's digital? I don't think that's a valid reason. So we're going to talk about why digital. What does it allow us to do that we can't do? What's the performance like? That kind of stuff. It's got to be better and offer more than FM if you're going to make a compelling argument not to use it instead of FM. So we're going to talk about some of the digital technology, probably familiar with that stuff, some of the logic behind Fusion, what you can do with it, and then we'll drill into more technical part of the presentation here. And hopefully all my live demos will work. Anyway, this is where Yaesu was founded. You know, the opulence of that building. It was founded around 1956, and that's Mr. Hasagawa, the founder of Yaesu. Sadly, is no longer with us. They initially made things like TV sets and toasters, and they eventually got into ham radio. Mr. Hasagawa is a ham radio operator, and quite frankly, that tradition lives on today. So they do avionics, they do marine. That's where they make all their money, not in the ham radio division. But it's kind of it's part of the company. It's part of the Japanese thinking. Also started in 1956. About that time was one Hasagawa. Hasagawa's son, who is now the president of Yaesu. So two things happened back in 1956. Yaesu been around making ham radio equipment for a long time. I mentioned their new FT101 XDR, whatever. So here's the original FT101 over here. I mean, if you go to the pages and you look at the history of Yaesu, and all the radios. I mean, it is an insane list of radios. I asked them at one point if they had a museum, which I thought that'd be cool if they had a museum of all the Yaesu radios, and they don't. But when you look at all the developments and all the stuff that's out there, you can kind of see it would be kind of tough to have a museum of all that stuff. And they had a number of innovations I wasn't aware of. The FT1 was an extremely expensive radio at the time, but they wanted to build the best HF rig that was all solid state. And that was not only the first solid state HF rig out, but it was a darn good radio. It still performs well in this day and age. And then moving along to, you might need to up the projector height a little bit. I have some Yaesu publications I can use. Okay. But this is some of the newer equipment and more of what we're going to be focusing on. I've got some of the stuff here. We've got the FT991. That's the radio on the bottom. It's one of the newer offerings. In fact, I don't know. I don't think it's too bad. It's 160 through 70 centimeters. It does all the modes, including Fusion, digital. It's got a built-in antenna in there, but I'm never a big fan of antennas in radios. And you know, it performs reasonably well. In fact, when it came out, we were surprised how well it performed. So it's not in the, you know, like a 718 and kind of that low-end HF class. You kind of have a middle range and a high range, which we could afford. This is sitting there kind of in the middle range, you know, so it's definitely above a beginner radio. The FTM 400 was one of the first Fusion radios. I've got that sitting on top over there. FT70D was kind of one of their newer HTs. Over here, the FT2DR, this is an HT I can show you also. It's probably actually the most advanced Fusion radio in the market right now. FTM 100, 100 and the 400 basically share the same electronics, just two less receivers actually, and doesn't have the touch screen. Then we have the FTM 3200 up here, and that's the one here with the kind of whoops. Oh, yeah, it's in this mode. That's brightness. So the FTM 3200 is a 2-meter monobander, and this is the FTM 3207. You know, they look kind of the same. Wherever it is, down there. And this is the UHF only version of it. Front-facing speaker, pretty rugged radio. Anyway, Yaesu divides the Fusion stuff, just so you know, into two. They have an entry level, which is the 3200, 3207, and the FT70D, and now the 7250, which I don't have pictures of. Those are the entry level, no GPS, no APRS, stuff like that. The non-entry level GPS, APRS, micro SD card for programming and data logging, you know, that kind of stuff. So just looking at some of the digital technologies, we have D-Star, which is the GMSK modulation. They run at a bit rate of 4,800. They encode their Vocoder runs at 2,400 bits per second and a forward error correction of 1,200 bits. That's pretty standard. What's different with D-Star is they use a very old vocoder. The D-Star has been around for a long time, 20 years plus, right? And so the thing with D-Star, it's made for ham radio and stuff like that, but the over-the-air technology is kind of left behind because the newer stuff performs pretty well. So when you add all this stuff up, they're able to eke out a few hundred bits per second of data while they're transmitting the voice. IDAS and NXDN, we have two of those repeaters in the state, and I operate one of them. And I probably have I'm probably one of the only hands in the state with a IDAS radio. But what it does, so it's at the same 4,800 bits per second, and that's how the voice and receive right down. ICOM kind of claimed the 6.25 kilohertz, but I'll show you later with occupied bandwidth on the spectrum analyzer. This is 6.25 kilohertz occupied bandwidth, so it's using 4 FSK instead of 2 FSK. And with IDAS, no bits left over, it's all voice. DMR, what they do, they're twice the bandwidth, so they're also using 4 FSK. The twice the bandwidth, but they do a TDMA type of thing, where it acts as 2 repeaters, right? So because it's doing that, you're doing TDMA stuff, you need more time in there for receivers to recover and preambles and all that kind of stuff. So their raw data rate ends up being about 7,200, which they split between the two channels. As a result, they don't have any room left over for data. So if DMR has to send GPS coordinates or anything else, it's got to do that in a packet that doesn't contain voice. So that's pretty much typically what happens. You key up, it sends all that information out, and then it's just voice data. Fusion has a number of different modes in which it operates in, and I'll get into that. Its raw data rate is 9,600 bits per second, still fitting in the same 12.5 kilohertz mask, which is the same as 5 kilohertz FM, by the way. So they're running, I have here, 2450 for the vocoder. By the way, all these guys use the same vocoder along with P25. So they're all. I mean, if you wanted to take the data from DMR, and people do this, and funnel it into a Fusion, you have to do a protocol conversion. It works. One of the things that Yaesu did, which was kind of cool, is that they in the DN mode they allow they restrict so you have all the space left over, right? Because, they're still got 9600 bits per second. They use it for another level of forward error correction. And that effectively increases the system gain by about 3 dB, something like that, by having that extra redundancy. They have another DN mode, and that's what's going on here. And I don't think that's right, but it basically gives you more data throughput. It basically gets rid of the final upside down. Anyway, it takes away that forward error correction and allows you to put data in that slot. So you drop the second level of forward error correction, and now you can transmit data. Then they have a voice-wide mode where they up the data rate on the vocoder and basically zero extra room left over. And so when you run that higher voice-wide mode, these vocoders are not meant to re-encode. They're meant to be at the microphone where it gets encoded digital, and you cannot change the quality of that audio after it's been encoded. So it doesn't matter, there's no volume or level control anywhere in the system other than the volume next to the speaker or the guy listening to it. So you can't change anything about the audio once it's encoded. So noise, like if you're going from FM to digital, will drive vocoders nuts because they're meant to be connected to a microphone, and they don't want to hear all this high frequency noise and PLs and things that might be in that FM link. They're very sensitive to it. When you use voice wide, it's much more tolerant. And if you re-encode, like let's say you took a D-Star, converted it to analog, and then digitized it again using voice wide, it sounds much better on voice wide than on the DN. On the top, I'm just showing the typical what a packet looks like. It's nothing new. Fusion uses C4FM. You might have seen C4FM on the literature. That's a specification from P25. That's the over-the-air specification. So generically, it's 4FSK, but specifically, exactly what's the deviation, what are the phase angles, what's the allowable delays, that kind of stuff, all those reams of specifications to make a digital system, that's covered by C4FM, and it's just a P25 specification. Why try to reinvent something that smart people already worked out, basically? And I don't know about DMR, whether they're C4FM or not. They might have some variation. You certainly have the TDMA, which is not in C4FM. So here's what I'm looking at here is on the spectrum analyzer, the D-Star and the FM occupied bandwidth. And we're modulating the FM with something 5 kilohertz deviation. And D-Star, initially when they came out, they would have you believe that they were like a 6.25 kilohertz bandwidth. You can kind of see there's a lot of material that goes out to 10 kilohertz. So they were telling coordinators you could take a 15 kilohertz channel, split it in two, and have twice the number of D-Star radios, and that just turned out to be a lie. You can't do it. I've kind of combined things here together. Red is 20 kilohertz, green is 10 kilohertz. The magenta trace is C4FM. So that's coming from Fusion transmitter, and it doesn't matter whether you're talking or anything. There's basically a pseudo-random number generator in there. Make sure you don't have strings of ones or zeros, and it's just going to keep modulating the thing. The cyan is a 5 kilohertz deviation analog signal, and just for the fun of it, the yellow is a FM signal with no modulation, and although I think PL was running there, so that's also a little thicker. But what I wanted to show here is that the digital and the analog masks kind of fit right on top of each other. And this was a design decision that Yaesu made. You know, they made this for ham radio. I mean, it transmits your call sign. We'll get into some of that. But they could have gone to 4,800 bits per second and half the bandwidth. But I think they made the right decision because us hams are probably going to want to play more with this stuff. And we're going to have more fun with the bandwidth. And obviously, you know, when you can add more forward error correction and you get an extra, you know, it's like doubling your power output, you know, what the heck? I mean, it's a new world where you can change things in the digital domain and it's like doubling your transmitter power. There seems something wrong with that. But anyway, we all know about the SK31 and, you know, FT8 and how they do that stuff. So, Fusion's performance, it has fairly good audio quality. There's a couple things they could improve upon, but the vocoders are pretty good now. It's more robust, and it's been interesting to be in the, you know, at the start of this. Because, you know, I don't know, guys, how many guys have run D-Star? Any of you? A lot of D-Star guys here. Have you ever heard of the R2D2 effect? It's like when somebody on D-Star starts to talk like a robot that can't speak English or something. Well, when Fusion first came out, it had that R2D2 effect. Occasionally, nowhere near as much as D-Star had it. And Yaesu kept coming out with firmware updates. So the Vocoder is done in the DSP in all these radios, so they can update the DSP. In the first update, the R2D2 is going on the way. And then, let me put it this way. If FM has a range of 100%, and I mean by 100%, not that it starts to get noisy, but it's a noisy signal. You can make out what the person is saying, but it's not something you want to listen to. Okay, so that's 100% of FM range. D-Star is probably at about 70% of that. And maybe when Fusion came out, it was about 80% of that. After the second release, we noticed it was just about as good as FM. And what you didn't hear the R2D2 anymore, and it seemed like they were able to do more recovery of information. So part of what the DSP is doing, I mean, there are no ones and zeros. They're all analog values that are coming in and needing to be interpreted. But through algorithms, you can improve, reduce your bit error rates, better error recovery, and it's essentially the same technology that all these commercial people are using. So there's a lot of money in here with people wanting to improve the performance of these things. One of the last updates that they did, I thought was brilliant. So when you kind of lost communications, it would just be quiet, and then it would pick up again. And you just know somebody was thinking, we've got a DSP we haven't been using. It's the one up here. And the EHF guy knows about it, the extra DSP processing up here. And what they're now doing is you'll get little syllables now and then. You know, when it can put together a syllable or something, it'll blast it out at you. And you can miss, you know, almost half of what somebody is saying and still understand pretty well what's going on. And so I would say now that Fusion is about 120% of FM. We did an experiment once. We had a guy out in Wisconsin, a guy here. They were talking on the repeater, you know, fine. And they said, let's go over to Simplex. And they did. And they were talking to each other fine on 2-meter Simplex. And then, okay, let's go over to try FM. And when they went over to FM, the squelch wouldn't break. They actually had to go and open up the squelch manually, and they could tell somebody was transmitting. There was a signal there, but that was about all they could tell. They go back to Fusion, and they were hearing each other just fine. So they've done some work in the signal processing that they can have extremely noisy signals and still pull the signal out. Another thing that needs to be easier to use, basically put in the frequency of you want to be on and start talking. You know, if you want to go on the Moundsview repeater, you take your brand new radio, 444.525 in it, and you VFO through the mic here on the digital. You do put your call sign into the radio, so you on the radios you see the call sign of the person you're talking to. Yeah, the not the entry level, but the higher level radios with the GPS in them and stuff like that. You also get to see the person's location or distance from you. It's actually kind of fun. And so I think it's better suited for D-Star and Fusion were both made for ham. DMR is kind of a thing. P25, the same thing. They're made for. P25 is mostly used in public service. For DMR, it's kind of like businesses and whatever. Some DMR and public service. But they're meant for like taxi cab companies where the radio shop comes out and installs the radios, and they don't want people fooling with the radios. You put it on 3, and that's where you talk. You don't talk anywhere else. That type of stuff. And the operator of the radio is completely clueless as to what's going on in the background. So things like DMR work extremely well for that because they in the background they just switch repeaters, use more local radio, patent it. All trunking and all this stuff is automatic stuff going on in the background that the taxi cab driver, the police officer doesn't have to worry about. Or the ham maybe. But I just think we're a little bit different. DMR and to some extent D-Star have this hierarchical structure. If you're going to put a repeater on the air, you got to connect to these guys and connect to those guys, and everybody's got to get along, and that type of thing. And Fusion I would characterize as moderated anarchy. And I think that works because look at the HF bands. It's the same thing as on the HF bands. It's on HF, it's like, okay, down here, if you want to do CW, do CW. You want to do FTA, you do FTA. Don't want to do anything, fine. You want to run this power, you need to get approvals from anybody to talk to anybody? No. You just do it. And so Fusion to a large extent is like that. When it comes to the networking and stuff, there's very little in the way of a central authority, and you get the stuff, put it on the air and do what you want with it. It follows where the industry is going, so we've got basically all the big players using the same radio technology that we're using. I'm sure it's going to, OFDM or something like that at some point will be in the future, I don't know. And you can do some interesting things. So Fusion was unique in that, you had simplex and repeaters. One of the things that's different with Fusion that I really like, and in fact, we were the instigators of it, was to do RF on-channel linking with a repeater. So you don't need internet at the repeater stop. Anybody with a wires, which is their networking system like I have right here, can just dial in the repeater frequencies, and now that repeater is connected to the network. In fact, when this became available to the public, nobody had to go to the 7,000-foot mountain to wish or change the repeater in any way. They just needed to load new software on their computer, and all of a sudden, network that was only available on their simplex radio at home was now available to everybody on the computer. So it's still the only system that can do that. They also have the concept of nodes, where you could take one of these radios, hook it up to your antenna, and drive 10, 15 miles around your house, and you can connect to whoever you want to. You don't need an MRC to approve a frequency. You don't need any authority to give you permission to connect. You just do it. And ICOM now has in their 4100, I think they have the concept for the node. But DMR can't do that. I mean, that's not what DMR is about, right? The way that Yaesu views it is this kind of their simplistic OSI diagram. You have a user level down here at the bottom. So users can talk to users, and users can talk to gateways. Gateways is like this wires Xbox. There's a new thing with IMRS, but I'm not going to be talking about that. It's available through the DR2 repeater. But gateways then are your gateway to the network. And so the networking, can really be what it's always wanted to be. It doesn't have to be internet. For IMRS, you can be on your own private network with no access to the broad internet and connect repeaters together. Works a little different from wires X. But the point is that these levels down here really don't care how you do the network. that type of thing. So that's basically how they envision it. The gateways are not supposed to talk to gateways, and that was the thing that we got an exception for with Yaesu that allowed the on-channel repeater linking without having to have internet at the repeater site. And just very simply, this is a big benefit of digital. So when you're talking on FM, you really just have the audio information. You know, digital, you have the audio information plus all these bits. So you can send information on the digital stream, providing the receiver with knowledge about what's being sent. In other words, I'm done transmitting and things like that. And that's why this all works. You really can't do this effectively with an FM repeater. In fact, it's so simple, it's beautiful. And that is, let's say I'm in Tallahassee, and I'm connected to a node in Minnesota. And I got my radio and I key up. And there's a node radio in Minnesota that key ups and talks to the repeater. So I'm coming out of that repeater in Minnesota and the repeater in Tallahassee. For a moment, that node radio is a virtual copy of that radio in Tallahassee. You could do this with digital. And so, a little exception, that node radio looks like it's the same radio that guy, if it's an FT2, that looks like an FT2. If it's an FTM100, it looks like an FTM100. And so, that's basically how, it's relatively simple, you know. And of course, simple tends to work. It does, WiresX does connect to other networks. Yaesu has reserved the right to be the authority on what can connect to WiresX. And I think that's a good thing, because you do need somebody to be the system engineer, because things get hacked on there, and now you got incompatibility problems, and whatever. Yeah.
Okay, I'm sorry, but I'm confused about one thing. I get the fusion part, but now we're talking about wires X, and some of Yaesu radios have got a button on them that say wires.
Okay, history of wires.
What is wires?
Well, initially nobody knew. Back when Yaesu came out with this idea of wires, then they had wires too. It's like if you have an FTM 7800, 7900, 8800, something like that, there's a wires 2 button on there. Wires X is the next generation, that's the digital. So wires, radio operation in Japan is very different from operation in the U.S. And so wires was always extremely popular in Japan. In the U.S., they sold less than 100 of these interface boxes the entire time Wires 2 was in existence. You'll be happy to know all those people that purchased the Wires 2 boxes got a free upgrade to Wires X if they wanted it, and now there are literally thousands and thousands and thousands of these interfaces in the U.S. So it really took on. What basically it was in Japan is people could set up these simplex nodes at their houses. There was a system, sort of a calling channel system, where you'd go in and, I don't know if Wires 2 could do this, but basically like if you're on the commuter train or something like that, and you find somebody's node that was available, and then you'd use the Wires 2 to go and connect to the buddies you wanted to talk to.
So the digital mode of some sort?
Wires X is the first time they allow digital.
Okay.
And Wires 2 has been deprecated. The servers are down. It no longer can be used. So everybody's been migrated to Wires X. So Wires X is the networking. Fusion is the radio part. I'll talk a little bit more about Wires X as well. There are, hotspots. You guys have hotspots at all? We're really a bunch of digital operators around here. Anyway, they have their own networking system. They have to talk to a server. Wires X does not have to talk to a server, because each node can be a server. One of the downsides is you need forward incoming ports, which is what a server means. And so in Wires X, If you had a Wires X station, I had one, I could call you directly. I don't need anybody. It's just you and me. They also have the concept of rooms, which anybody who has a node can also have a room, and then multiple people can simultaneously connect to the room. So anybody that's bought one of these HRI 200s got a node, and they have a room, and they can name it whatever they want. They can invite whoever they want. Really no restrictions on it. But these hotspots don't connect to Wires X. So what ends up happening is that magic. And the Wires X system, and some kind of bridging operation takes place. You connect into one of the servers that the hotspots connect to. It's never as good as connecting to the primary network. This is UDP. You've got more opportunities to drop packets and things like that. But it can be done. If you're interested at all, I can demonstrate some of that stuff if there's time and there's interest. So one of the nice things is this AMS. And of course, there's a problem in going digital. I tell a story about a friend of mine who years ago, he got a D-Star system. And of course, you spend a lot of money for a radio. Who asked the question?
Oh, thank you.
You got a D-Star radio, and of course you get something new, you want to use it. I didn't talk to him again for a year and a half. And I couldn't afford a D-Star radio. Those things were expensive. I lost my mouse. There it is. So the problem Yaesu had was, how do we get this stuff out there? So they, one of the things that they did is they made it so that their repeater could do FM or digital. And also same is true with the radios. And, I can demonstrate that. So when we first started out, and we were one of the first, there's a 100 beta test sites. We were one of them before it came out. And, nobody had digital radios. For 5 months, I talked to myself and one other person who I never talked to again on digital. And then Yaesu days happened at Radio City, and 5 or 6 people bought Fusion radios, and hallelujah, I can talk to somebody else. And then, kind of took off from there. But you have to be respectful of the FM users. You don't want to be like this buddy of mine I didn't talk to for a year and a half. So we worked it out like from drive time, you have to use FM. And then maybe at night, okay, you get to play with your toys. And then as more and more people got digital type stuff, we said, okay, well, here's what we'll do. You can use digital, not during drive time, but if somebody who's on FM and they just see the repeaters being used, and, of course, it's digital, so they're not hearing people talking, if they just come in and give their call sign from between transmissions, we'll bring them in and I'll switch to FM. It's like you have 2 Germans in the elevator and you walk in there and suddenly they're speaking English. It's just polite. And so that were the rules. And the way the equipment works, the mode select is if you transmit digital, the repeater switches to digital, and the radio's listening to the repeater switch to digital. If you switch your radio to FM and transmit, the repeater switches to FM and all the radio switch to FM. So basically, when the guy came on and gave his call sign in FM, all the radios automatically switched to FM. And we were talking in FM. And that helped. And in our organization, how do you convince people to try digital if you don't talk to them? Right? That was one of the things with D-Star. I think there was this divide, this digital divide. And didn't know what was going on in D-Star unless you had a D-Star radio. So that was kind of nice. Now the repeater still does AMS, so you can still switch to FM. One of the downsides of that is we have a network, so if network traffic comes in, it'll pump it back to digital, and that's it until the network traffic quits. One of the other things that Wires X enables is both analog and digital. So you can set up a node or a repeater to be FM or digital, and people can talk to each other. Now, to be honest, the FM going to digital doesn't sound as good to digital going to FM. So we much prefer people running digital. But it does work. You can have analog and digital repeaters. There's on 145.23 in Shasta. That's an analog repeater that's on the dark digital amateur radio program up north. It's the only analog repeater on the network. But all the other repeaters are digital. But if you're on Shasta on 145.23, you can talk from that digital network. That's what all this is about, on the pictures. There's a group mode. I won't say too much about it, but if you turn on group mode and you've got one of the fancier radios with a GPS, you have a screen that builds up. These radios basically ping each other constantly. And so net control can look here and say, oh, okay, this is the guy that's transmitting. He's got the red box around it. These guys are in range and active, distance, or relative signal strength. This guy is timed out. He's probably not, I probably can't communicate with him anymore. And of course you can tap on him and you can get their a compass and direction and things like that. And so you have this constant pinging, so if you have stag wagons or something like that, you can always keep track of where they are. So you can have up to 24 people in this group. In our analog system, Yaesu has this ARS, automatic responding system. This is kind of the digital analogy to that. There is also a camera available, so you can take pictures. I happen to be one of the few.
Not video then, right?
9,600 bits per second? No, it takes a while. I'll demonstrate that. No, it's not video. It's basically a low resolution camera. Try doing that on FM. So the future of this stuff is we don't use digital just because it's digital. We use it because it's compelling and it allows us to do things that we couldn't do before. And ham radio, we're in the business of communication. And to communicate effectively, you really just take whatever tools you have available to them and you sort of work them together to find the best possible solution. What we can do that police departments can't do, and us in the military can do this, right? So if fusion is going to go anywhere, it's because it's compelling. It's got to be simple. You've got to be able to go in Radio City, get a radio, on your way out, program in the repeater, and talk to somebody on digital. It's got to be that easy. And basically, the features need to be powerful. Like they enable you to do incredible things, and they have to be simple. It sounds like somebody else had that philosophy. It was Apple when they came out with the iPhone. So it's kind of known that you have to do this if you want to be successful. So this is kind of an older slide, but I was just comparing FM and traditional digital. I mentioned like sense of community, kind of isolating. One of the things I really like about the Fusion, the Wireless X, is I've met so many really neat people on here. It's like everybody's been recharged. People say, an amateur radio is dying and stuff like that. Not over here. It's just, young people getting into it. We had a guy in his 80s, Ozzy, over in Cable, Wisconsin. No clue what he was doing. Got a node. There are no repeaters in the area. Got the whole thing kind of working. We had to send somebody over to help him out a bit. But, man, he's 80 years old, and he just dove into it. I kind of give the guy credit, right? One of the, I guess one of the downsides to Fusion is also an upside. And that is, it is not as mature as these other systems. D-Star's been around for a long time. Of course, DMR's been well figured out and stuff like that. But DMR is not going to be changing. You're not going to get these radio manufacturers to make any significant change to the amateur radio community because the money is not there. The money is in the commercial. Target wants to buy some HTs. They're buying 120,000 HTs. Radio manufacturers, when you design an HT, that's their entire production line. And that's just the date for the purchasing agent, for when these other radio companies. You're not going to see ham radio, or fundamentally you're not going to see DMR change much from what it is today. D-Star has a potential to do some changing. I personally think ICOM has blown it by not having a migration plan to get off of GMSK and go on to something like C4FM. I mean, IDAS, which they sell, and I have an IDAS repeater. It's beautiful. It's got, in fact, the digital board is the same board that's in the D-Star radios, except it's got different firmware in it. It's DSP. But somewhere, they weren't thinking like, we've got all this cool stuff over here with IDAS, we could adapt it to ham radio. And they're off on this D-Star thing. And I just don't get it. So Fusion has its growing pains. I have a lot of cuts and, bandages and stuff from the growing pains. It's gotten a lot better. The one thing that I found fascinating was that here's a company actually listening to hams to figure out what they should be doing. And so I personally have several features in Fusion that I was able to convince them to do. I'm working on a couple more right now. Not easy. It takes some serious convincing, but it can happen. And so, like the linking, on-channel linking to the repeater, that was not something the Yaesu envisioned. In fact, fun fact, another hat, I can see another hat when you get my way. How many Fusion repeaters are there in Japan? No looking at the repeater book. Anybody? What?
100,000.
Okay, I'll give it to the closest person. Anybody else have a guess? 100,000 repeaters?
600.
600? Anybody else?
None.
Who said none?
Not because you told us you don't need a repeater to link this up, right?
There are no Fusion repeaters in Japan. It is illegal to run a Fusion repeater in Japan. And it's just how Japan works. The Japanese Radio League is really sort of a political, semi-government entity.
Fair.
Yeah,
Is that because the D-Star people are protectional stuff there?
you bet. So when the JRL was formed, there were a lot of ICOM people on it. And when ICOM says that JRL developed D-Star, well, it's a little wishy-washy exactly what that is. And the way the politics work for the JRL, when you retire from the board, you get to pick your replacement. And the government listens to JRL in establishing amateur radio regulations and guidelines. So you can have a D-Star repeater in Japan, you can have an FM repeater in Japan, but you can't have a Fusion repeater. So it's been part of the problem because the people developing this stuff don't have the ability to run a Fusion repeater over the air. So you can imagine how tough that makes that. So what's the popularity like? By the way, Repeater Book's a nice place to go. I recommend you use that, and it's an amateur radio, user-supported, run, contributed, edited. It's fairly accurate, but I broke out a couple of the nearby states. Generally, it's kind of leveled out now. The last time I did this was following the trend of DMR and Fusion cannibalizing D-Star. So the number of D-Star machines is down quite a bit. There was an uptick on, I'm sorry, did I say that right? D-Star is down quite a bit from where it was. There's a bit of an uptick. I don't know whether that's real or not. Numbers have kind of stabilized that I have seen. I would suggest it's not a good idea to invest a lot of money in 2.5 or an XDM. So anyway. So this is just looking at the number of repeaters out there. It's not D-Star has a lot of hotspot activity on it. So I would say D-Star is, mostly becoming a hotspot mode. Really. Anyway, so the point here is that there are a lot of Fusion repeaters out there to use. I did a map of Minnesota here and all the Fusion machines in Minnesota. There are two large networks in Minnesota. One is I mentioned the DART group. They're from up in this area over here, and I actually really color which ones are theirs and which ones are ours. So for MinWiz, which is our network, we have a machine here in St. Cloud. There's one sitting out over here in River Falls in Wisconsin. We've got Burnsville, Richfield, Dayton, where Dayton is, and Mounds View up here. And our piece de la resistance is this guy up here, which is on top of a very tall tower on a very high piece of ground. And it basically covers from Forest Lake through two harbors. So it's basically covering a pretty good section of territory from up there up to there. But it is way up there. It's many hundreds of feet above average ground level. The end result is you can drive from Menominee out past St. Cloud and never lose coverage, or up to Duluth and never lose coverage. And so a lot of these, for the dark and MinLiz, a lot of these repeaters are permanently connected together. We have a net on Monday nights where other people will join us, and repeaters from down in these areas here will join us at other times. They tend to switch around a little bit more. A typical net, we will have maybe 110 wires X connections and like 40 type hotspot type connections. When we do check-ins, which we hate to do, we get between 120 and 150, and due to some analytics, we tend to guess that for average nets we have between 800 and 1,000 people listening, but not everybody will check in. When we have a popular net, we might have 1,200 to 1,400 people listening. And when you look at the repeaters that are connected, it's global. You know, we've got folks in Australia, Philippines, Trinidad, UK, all connecting, plus a good number of the states are represented. Or you can keep it local. So dark is more of a local network. It's pretty much a Minnesota only. It doesn't prevent anybody from joining it. We're local, plus we have these relationships. We've been an incubator for other groups. And so there's the Texas Nexus and DARK and some of those groups we were incubators for. And we're quite happy to see them go off and do their own thing. So I don't know whether it's foolish or not, but at one of the Yaesu days at Radio City, I predicted that'd be the dominant mode of operation in 10 years, 2025. And by that I mean VHF and UHF. There will be more fusion traffic than all the others combined. It'll be greater than any of the others.
Do you mean strictly digital or
fusion? Just fusion. It'll be more than DMR, it'll be more than FM. Okay. FM's the big one. The reason is, you asked a question, didn't you? The reason is, we know things already. The phones go from digital to analog or analog to digital. How many analog cell phones do we have? Anybody?
Zero.
Is the cost of silicon going down or up? You know, and one of the problems with the digital has been it's been very expensive. You know, you try to use 1990s technology to solve these problems. It's tough. But now, with the integration of, you look at like Bluetooth chips. The whole damn radio, in fact, I've got a chip that has Bluetooth, Wi-Fi, and the antennas are on the chip. You know, it's just a little piece of silicon for like $2 in the Raspberry Pi. And it's like, and you look at frequency hopping spread spectrum, you know, and all this kind of stuff. So the digital stuff is going to get more economical. And as we're able to apply more power in the algorithms and the signal processing, analog solutions just can't survive as well. So the reason I say that is, one, it's going to perform better than FM. We're already seeing, this radio here, so it used to cost $190 to get the D-Star add-on board for your ICOM radio. This radio, when it was introduced, it was selling for about $140. This is a 65-watt monoband FM radio. I bought the UHF version. This was my 40th, invention for $145. This radio, dual band HT, single receiver, no GPS, is selling now for about 170. I mean, the FT60, which was FM only, sold for about 170. You know, so that's what I'm saying is you're starting, and this is, I mean, even if you never used Fusion, this is still a good HT. You know, so here you can get a perfectly nice, this is about $1,100 for this radio. Not bad, right? And you get the Fusion in there too. So that's kind of, you just want a half.
No.
What?
Sure. Fusion is predominantly, or maybe exclusive right now, 2 meter 440.
Mm-hmm.
Well, is there any kind of vision of expanding that to other UHF bands or is it HF? Or is that not practical?
I don't know if Yaesu will do it. I think there's a spot here where us hams do some of it and Yaesu does some of it. I will guarantee you, no organization of amateur radio operators can design and build this. It is so far, you look at, there's over 1,500 parts in here, and you look at, I mean, just building an HF amplifier and getting it not to oscillate, you know? I mean, you look at the technology that they have in building these things, we can't do it. So I guess my vision is, I want a radio company to make us radios we like and we can carry around and stuff like that. But all this networking and other stuff, that's what we're good at, right? You know, we can write software, and I'll show you some of that if I get to it. So I think there's a place for us, the experimenters, the doers, to do some of it, and for Yaesu to do some of it. And quite frankly, we're the innovators. You know, the innovation happens. I mean, the Japanese are extremely good engineers, and they do have their innovation, but you want to hit the innovation out of the park. There's just a few countries where that happens. You know, you have like here, Germany, you know, a couple other countries you can think of, England maybe, whatever, and that's where a lot of the real serious innovation comes from. And I think we can have a lot of fun, you know, if we can kind of do this together. So 220 megahertz is not economically feasible. We're the only country that has that band. So they will, I'll guarantee you, it's just economics of what it costs to put a radio on the market. You're not going to see a radio come out that can't be sold in virtually every country. You know, I mean, they have huge markets in Europe and Japan and stuff like that. We're a fraction of what they sell. I mean, a big fraction in radios. If you look at the vocoders, they are fascinating technology. Now, there was a rumor out there that these things were expensive. Zycom wanted to justify their $190 for it, in my opinion. But you can buy the vocoder chip, which contains the license for the vocoder, TI chip, 100 quantities, $15, something like that. This DBSI is the name of the company, and they've come out with a new vocoder that all the satellite people are really, you know, if you can double your traffic on the satellite, you've got something. That satellite just became a half-off deal, you know, and they're down to 1,200 bits per second and getting what they claim the audios we have now. So you go on their website and you can listen to all these encoders. This is how they test them. They'll have rooms of people listening to this, and they'll have noise and environments and bad signals and stuff like that. And the question is, did you understand what the person said? And that's how they develop it. With 1,200 bits per second, now you can probably get on HF and stuff like that, but you need a different modulation scheme. The C4FM won't work in HF. Yes?
So the satellites, you're dealing with Doppler shifts.
No, this is geostationary.
Okay.
This is not amateur.
Because my question was, because a couple of years ago, I was in one of these digital, you got rid of the R2D2 effect, but they also noted the effect because they're one of the guys was installing digital systems for public safety.
Yeah.
Police cruisers go over 70 miles an hour and the signal drop off because of Doppler shift. So
No. Somebody's pulling your leg.
Well, that's what the problem they identified.
The TCXO on the radio is not that good. No. I'll guarantee you, I'm pretty sure the number of people with Fusion have driven faster than 70 and it didn't have a problem. Yeah.
Do you know what the sampling rate is in the vocoders?
I don't know specifically. You can get a vocoder kit, you can get the data sheet from DVSI. They're, depending upon the design, I mean, they're, oversampling, of course. There's two ways you can do this. You can take the output of the discriminator and feed it into your A to D. Or you can take the output of your IF and feed it into your A to D. So in IDAS, they take the output of the IF. In Fusion, they take the output of the discriminator. And it surprised me that they could do such improvements in performance and still be taking the output of the discriminator. I mean, a nicely designed discriminator. You've got fundamentally all the digital radios, ICOM as well and whatever, extremely good IF filters, much better than just an FM only radio. And linearity and all that stuff is really well controlled, although you don't need a linear system to do C4FM. Anything that'll do FM will do C4FM, so you can run a Class C and whatever,
I don't want another half, but you mentioned frequency hopping before. Is that legal for civilians to use? And if so, do you see a future for that in amateur radio?
Hams can use frequency hopping. You just have to be public about your hopping sequences and stuff. I don't think so. And what frequency hopping is really good at is when you have mass chaos and nobody knows what frequency to use. It's inefficient because you're going to get collisions. So it's more efficient to not do frequency hopping and manage the frequencies. And so the Wi-Fi Alliance is working on a answer to Bluetooth where they get multi-kilometer ranges and stuff like that. They have antenna steering built on the chip and all that kind of business, variable data rates. And they were using a cooperative method of channel management between all the stations to avoid the collisions. You see funny things like I did the research on Android and iPhone, and their methods of choosing frequencies on like Bluetooth and stuff are completely different. And frequency output, the cams do use it. I mean, we've licensed for this 2.4 gig band, and we just use the regular old Wi-Fi stuff and have fun with it. We do have a net Monday night, 7:30. I would like you to remember hamoperator.com, because if you remember that, you can find everything else out that I'm talking about here. Our net is Monday night, as I said. This doesn't make any sense to you. We're in the MinWiz, which is Minnesota, Wisconsin. We just named it that. Who knew it would become popular? It's in ring 21493 and FCS 002-23, bridge to hotspots. You can also listen live on hamoperator.com. There's a link to click for internet streaming. You have a Broadcastify app in your phone. You can listen to it there and you take email check-ins and stuff. Yeah.
In the Twin Cities area, are most of the Fusion repeaters VHF or UHF?
Mostly UHF. The only VHF, well, we've got the analog machine. The digital machines, the only one that's digital is Richfield. They're on 145.39 and they're connected to MinWiz. If you're going to buy a monobander for Fusion, you want the 3207 or the 7250, which is a dual band. And then there's the stack at Mounds View. This is the Fusion repeater here. This was the backup repeater, which is now gone because it's going to FM. This is the ICOM IDAS repeater here. SCOM controller is connected to the ICOM, but it's also used in bridging the two together. So I can simulcast on analog what's going on digital. And we do that, but I should have mentioned that to the net. 444075 is this guy. It is up in Mounds View, but when the net takes place, the SCOM automatically switches to bridging mode. We have a 2-meter remote base, which is right there. We keep track of number of transmit hours and key-ups. We're at 4,000 hours and 700,000 key-ups at this point. This is monitoring the power amp, so we're at 11.4 volts and 17.4 amps times 2. Power supply for the remote base, power supply for the ICOM system, and this power amp. So that's kind of the stack. There's a shiny antenna that's up on the roof. It's a Hustler. And boy, does that thing work nice. So on the ham operator, this is one of the reports we generate. This is the last heard report. And it gets generated about every 30 minutes. And what you see here is the call sign that's been programmed into the radio mostly. Over here, you'll see things like F5L29. That's a transmitter ID that's being sent. The question is, let's say I'm K9EQ and I have 3 radios. And I transmit on my radio. How does the system know which radio I'm transmitting on if I've all programmed it with K9EQ? D-Star follows up by saying, no, don't do that. Add some stuff on the end. Fusion solves that by putting a factory etched serial number into your radio called the personal ID or the transmitter ID. So every Fusion transmission has this 5-character sequence. From the prefixes sequence, you can find out what kind of radio somebody has. So, just to be helpful, I list the types of radios that people are using. The local here just means they came in on the repeater. This would be the 525 repeater in Mountain View. It just means we received them locally versus coming in on the net. And this is the last time we've heard them. At the top, I keep a list of all the different kinds of radios that I've heard. So in this particular one, you've heard 119. I've heard a DR2X repeater. That should never happen. We've had 14991s, 13207, 43200s, 29 FTM 400s, 26 FTM 100s, 16 FT70s, 15 FT2s, and 13 FT1s, which is discontinued. This is also a list of who's connected to MinWiz. So it's telling me at the top that we have 84 nodes connected. We have 56 digital nodes, so those are nodes connected on wires X. We have no analog nodes at this time, and we have 28 hotspots connected. So that's what it's telling me, and then here's the list of who's connected, what their node number is, because all the wires X stuff has a node number, where they are, the frequency that they're on. I also do a active node list. So if you're going to be somewhere, it's sorted by country, state, and city. You can look it up in there. And repeaters are on wires X will appear on the node list. But people that just have a node set at their house will appear there also. And these are active ones. These are ones that were on the air, connected to the internet when the report was generated. And so if you happen to be traveling somewhere, couldn't hurt to look it up. And it's a repeater. Generally, it's a good idea if you want to change rooms or something where you are to make sure people are good with that and always put it back where you found it. Whatever room it was on, the repeater or whatever, to make a note of that, and when you're done, put it back where it was. We recommend just making sure you know what the policies are of the individual repeater, but as long as you identify and don't put us in the Japan room. We're pretty good with that. Believe me, we've listened to Japanese for 3 or 4 hours before I realized this was going on. Anyway, this is kind of taken during our net. This is part of the control panel for the WireTech software, and it just shows kind of a list of some of the stations that happen to be connected at the time. You can see a BK in there and BEs. We've got pretty good relationships being in Minnesota, Canada. We've got a ZL. So you can see we get stuff from around. In fact, people have commented it's easier to work DX on Fusion than on HF. Yeah, it doesn't count. So that's the end of the generic presentation. It took a little bit longer on it. We've been asking questions. So I'm gonna move to the technical part. Some of the stuff, well, the point here is getting back to the idea that we can do stuff and they can do stuff, and when we work together, it's great. So that's kind of the theme here. What I'm showing you in the picture is what the repeater looks like. This is a DR1 repeater. What you have is there's a battery backup circuit and power distribution here. AC power supply is here. This is the receiver. You've got a couple display unit and stuff like that down there. Transmitter over here. Now you have a fan here and a fan there. When you have the cover on, you have kind of a wind tunnel where the air comes in through here and down through here, comes around here, sucked through the fan and sucked through the fan on its way out.
Isn't that redundant?
Hmm?
Isn't that redundant?
No. It creates a nice, what it's doing is it's creating a nice wind tunnel in here. So that's where you want to move most of the air through. The fans have different algorithms, but a lot of systems you'll see that the fans are internal, not external, because they're quieter that way. So it works fine. I'd rather run the thing cooler than hotter anyway. Here is a secondary DSP filter, which looks like it's being used to help with the FM to digital conversion. Talk about that. Yaesu publishes a document called Amateur Radio Digital Standards. That's public. It's on the Yaesu website. And what I'm showing here is the scope of that publication. So what it covers is basically the over-the-air part of Fusion. Takes care of the transmission, reception, stuff like that. What it doesn't cover necessarily is detail on how all the bits get used. But it tells you where the bits go, how you can package them, and we'll show you more of that later. This is just more detail on the different Fusion modes. You have DN1 and DN2, and I kind of mentioned what they were before. You either have a port error correction or not. You have voice wide, and you have data wide. So data wide is about 72 per second. And this is a C4FM mapping here. So you have the die bit and the symbol, what the deviation is for both wide and narrow. So there's a wide 12.5 kilohertz mask, and narrow is about a 10 kilohertz mask for Europe, something like that. You don't want to use it, because it just decreases the system gain. So this is what the packets look like. You have, when you key up, you get a header packet, and this has things like the call sign and all this kind of business, and you get a copy of the slides. You have communication packets, and you have a terminated packet. So when I transmit a header packet, has all the information about me in it, and then I start blowing out communication packets for as long as I key down. And when I let up the key, I send out a terminator packet. If you hear a beep on the radio, that means the radio received a terminator packet. Basically end up message or something like that. If I go and break the data section down, so what we're doing is we're transmitting these, we have FM0, 1 to FM7 maximum, it can be FM6 maximum, that type of stuff. We keep repeating these frames, and in these frames you can have data and voice. These are bits here. You have an FICH at the beginning, so you got training bits, FICH that contains information about the packet. This is 100 milliseconds worth here for 960 bits, 600 bits per second. So this is for the communications channel usage. And so it changes a little bit depending upon what mode you're in. Do I have less voice or whatever? Same thing for voice wide and data wide. So here you see data wide, we're sending nothing but data. Here we're sending nothing but voice. And I got a little tool that lets me scoop in on Fusion and look at this stuff in real time. If you want to see that, we can play with it. Here's you can look at the over-the-air data. You can use a receiver to demodulate the data, use the software to process it. I've been playing with this DB4 Mini. There's a thing called DB4RX, which is on GitHub, which I fixed, so it crashed all the time, and making it a little easier to use. I have a version of that up on hamoperator.com if you happen to have a DB4 Mini. However, I'm very suspicious the company that makes the DB4 Mini is going out of business. Let's see, you've seen something kind of similar to this, where we've got the node and some of the way the WiresX stuff works. So familiar with radios, HRI 200, internet. So Yaesu maintains a list server in Japan. That list server just keeps track of who's connected. Because if you want to connect to somebody else, you need another IP address. And what you do is when you basically turn on your system, you go to the list server and download basically lists of the active nodes and rooms and their associated IP address. And then from there, you have rooms and reflectors. After you've done this part, all of this stuff does not involve the Yaesu list server. So the traffic that you're sending is not going to Japan. Information that is there is going to Japan. So it's a distributed thing. I mean, it's a good thing for them, right? Because they don't have to worry about a server somewhere getting overloaded as the system grows, because it's distributed processing. In some cases, we've read that's a good thing. Slide is messed up. So basically what you have when you have the system set up here, you got the internet, it goes to software running on your PC, sorry, no Linux. There's USB connection to the HRI Yaesu. I want to pass one of these. I have a radio I can pass around. No, that doesn't have the connector on it, sorry. Where the packet connector was, I think it was like a 6-pin connector for packet. This is a 10-pin. And it adds a digital, so you can do the digital and the analog at the same time. So this cable here, all these radios have a 10-pin connector with a packet connector. It still doesn't packet, by the way. Inside the radio, of course, you have a main CPU, but signal processing and display CPU pretty typically. When you put the radio in the WiresX mode, and you see the one with the blue screen down here says WiresX, you're not seeing frequencies on it. It's being controlled by the HRI 200, which is right here. So the radio's been completely taken over. That's why, I accidentally bumped this button earlier and the screen went out. Well, the channel selection knob now becomes the brightness knob. The volume doesn't do anything, whatever. So one of the things, you guys familiar with Wireshark? You can use Wireshark, and there's certain ports that get used, and you can go in and snoop on things. And what I've done here is I did a capture of a list server request going out to the Japanese list server, and the response coming back on it. And you can kind of see in here, you see things like megahertz, and swell, frequencies, and call signs. So you see some of the data coming back from the list server. And it's all done with UDP and that kind of stuff. This is my request going out, I suspect. The call sign is in there, and this is my node number right here. So you can go and kind of look at some of the data. This is why I think we can help them. So there was a problem observed that we can do this bridging with the hotspots, and some people use DMR radios on their hotspot to talk on the Fusion network and vice versa. So in this case, the guy had a DMR radio. The call was AV3GD. It was called, and stuff wasn't working. So I would hear him coming out of the WiresX node, but it wasn't going through the repeater, and it was going through the repeater, but it wasn't propagating out on the WiresX network, so nobody else could hear him. Well, there are two major differences that a Wireshark analysis showed, and that is you have 10 characters for your call sign, so some people put their name in there, like I did there. His name's Ed, he got it made. And there's my transmitter ID, E54DD. Looking over at the DMR transmission, so basically, I forget what was happening here, but basically, this was filled in with spaces, and that's not what Yaesu uses to fill in blanks. So it isn't like that, and then of course you'll notice where the transmitter ID goes, no transmitter ID. DMR doesn't have one. And I suspect those two differences were causing it not to propagate through the system. Because there are things we can do now in WiresX that transmitter ID is useful. These are the ports that get used. Off the list server, control, room, whatever. The way the analog and digital works is if you're a digital station, you transmit both an analog and a digital stream. If you're a node. Because you have a vocoder. If the guy's coming in on digital, the radio you're using for a node has a vocoder, with a digital radio, and it can convert the digital stream to analog, and so from your server you send analog and digital out onto the network. At the other end, if you're a digital node, you just pick up the digital and use that, but maybe you're only got FM, which doesn't mean you have a Yaesu radio. The only thing you can do is listen to the analog stream. So that's kind of how they do people can do FM and digital at the same time. If you're an FM only node, you can only transmit an FM stream, or an analog stream. Analog, right, it's digital over the internet, analog. The analog stations can listen to that, and the digital stations, guess what? They have a vocoder, so they can convert it to digital. So that's a sneaky business that they're using. They have like newsrooms, and there's a web access port and stuff, but I'm not going to really use it. You can store pictures, messages, things like that can be called, whatever. Anyway. So this is a voice data capture. What is this? Yeah, so I think this is the initial handshake. So we send out something that gets to JPEN wires info-en-sv update info.bin, and we get back a file, and that's what starts everything off. It has the IP addresses for the servers and all that kind of stuff in it. This is the type of data that's sent. We've got the hello, we've got heartbeats that occur both to the list server and whatever you're connected to, status information, control information, and of course voice. So those are the different types of data that Fusion transmits. And this is just a picture of the WiresX console. So here we have all the stations that are connected. That's kind of what's represented up in the list here. All this can change for other things. This is the list of all the active nodes, and this is the list of all the active rooms in the country, or in the system. Right here we have all JA. This is the room I was mentioning. The repeater was speaking Japanese for a few hours. They have 161 connections. Miracle link to the popular U.S. room, that type of thing. This is a list of stuff coming and going. Over here, this is a PSR map transmitting on FTN 400D. The uplink is K9ET with 1138 for whatever reason. Here, there's a text box where people with the software can type in a text message and everybody who's connected gets to see it. And I kind of showed you some of this stuff. The reports that are on hamoperator.com are generated by artifacts that the software produces. Most of them are intended for us to use them. Others are not intended for us to use them. The Plaster station is an example of that. That's not a file that's public. Dig for that a little bit. Analysis tools, I basically use Wireshark. The Scanna Studio, FTDI stuff, right? You guys familiar with all that? That's great stuff, man. They make these cables that do everything. You want to tap into like a JTAG port, or you want to monitor a serial communication line on something to kind of reverse engineer it, They got the cables, so check out FTDIchip.com. Scanna Studio is a logic analyzer that I really like. The logic analyzer is relatively cheap. It's like this little box here. So you get like a 4-channel, 8-channel, less than $200. And about what you get, less than $100. It's really nice. The good thing is the software. The software is fantastic. You have to buy their stuff to use the software because they do like to make money. but it's the same software high-end stuff uses. Exactly the same. All it reads is their little box. And, like a 4-channel thing, 40 megahertz or something, great for what we would do. If you want to go in and look at these serial buses, like the HRI 200 and the FTM 100 or something like that. And of course, I suggested any good hacker would have an oscilloscope. So I just list some resources here. Some of these are probably familiar to you. They're all in the show notes. And I guess that's it.